Hello there, and welcome to the Sleepy Science Hub channel. Tonight, we'll be drifting through the dark, mysterious depths of outer space and discovering one of the strangest phenomena in our universe. Void galaxies exist in total isolation, in regions of space so vast and empty that it's hard to comprehend. They're like remote desert islands floating through a sea of endless darkness. Most galaxies exist in groups. They cluster, collide, and affect each other through light and gravity. But void galaxies are different. They shine in immense expanses of nothingness, where neighbors are few, and where the familiar bustle of the universe seems to fall away. And yet, these lonely galaxies are not lifeless. They spin, they grow, they form stars, and they carry on in places that seem almost too empty to hold anything at all. Tonight, we'll wander into that astonishing emptiness and explore what it means for a galaxy to survive on the farthest edges of space. We'll gloat hidden structures, strange signals, and the vast unseen forces that shape the universe. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too, one sleepy soul at a time. But for now, all you need to do is get comfortable. Let your body soften and allow your breathing to slow. And as the day begins to gently fade away, join me as we explore these rare galaxies together. Let's begin. Void galaxies live where the universe is eerily almost empty. In most directions, there's almost nothing nearby to answer them. Our own galaxy belongs to a busy arrangement of neighbors, satellite galaxies, and long streams of matter. These systems do not. They inhabit enormous cosmic hollows called voids, where the distance between one substantial galaxy and the next can become astonishing. That emptiness is not a poetic exaggeration. It is a measurable feature of the large-scale universe, mapped by surveys that reveal great walls, filaments, and between them, immense underfilled regions. To find a galaxy shining in one of those vast hollows feels almost uncanny, like finding a lighthouse in a desert with no sea. And yet these places are real. They tell us the universe is not spread out evenly, but arranged in a grand pattern of crowded knots and deep gaps. Some galaxies are born not in the bustle, but in the loneliest terrain imaginable. Some galaxies drift millions of light years away from any crowd. If you stood inside one of these remote systems and looked outward with impossible eyes, the wider universe would feel far less crowded than it does from the Milky Way. We live in a region threaded with nearby galaxies, including Andromeda, the Magellanic Clouds, and countless dwarfs bound to larger structures. In a void, the nearest substantial company can lie millions of light years away. That is distance on a scale so large, it almost stops meaning anything human. Light itself takes ages to cross it. Gravity works across it, but patiently, weakly, and over immense spans of time. A lonely galaxy in such a region may spend billions of years without the kind of close encounter that can twist a disk, trigger a major merger, or fling stars into chaos. It is not merely far from a neighbor. It is living in a version of the cosmos where company has become an exception instead of the rule. Cosmic voids are the largest lonely structures we have ever found. Planets can be isolated. Stars can wander. Even galaxies can end up in sparse neighborhoods. But voids are larger than all of those ideas put together. They are among the greatest structures in the known universe, spanning tens or even hundreds of millions of light years. These are not objects you could point to like a planet or a comet. They are absences with shape, regions where matter is far thinner than average, because gravity has pulled more material into filaments, clusters, and walls around the edges. In maps of the cosmos, they appear like vast bubbles between brighter strands, giving the universe a texture almost like foam. Their scale is what makes them so astonishing. A single void can swallow distances that would contain countless ordinary galactic neighborhoods. When astronomers study one remote galaxy inside such a realm, they are not just studying a lone island. They are studying life inside one of the biggest emptinesses nature has ever made. A void galaxy can shine inside a darkness bigger than imagination. That contrast is part of what makes these systems so mesmerizing. A galaxy is already an extravagant thing, full of stars, gas, dust, dark matter, ancient light, and often a black hole at its heart. To place such a structure inside an enormous, underdense region changes the emotional scale of it completely. The light becomes more dramatic because the surrounding emptiness is so profound. It is like seeing a city glowing where almost no roads lead. From far away, the galaxy still looks ordinary enough through a telescope, perhaps a blue spiral or an irregular smudge. But when astronomers place it in its true setting, the context becomes astonishing. Around it lies a region where matter is scarce on scales too large for instinct to grasp. The galaxy does not stop being a galaxy, but it starts to feel like a survivor, a bright concentration of order suspended in a realm where the universe has left much of the canvas nearly untouched. These galaxies grew up with far fewer collisions than most others. That matters because collisions and close encounters help write the life story of many galaxies. In crowded environments, galaxies pull on one another, steal gas, stir up star formation, distort spiral arms, and sometimes merge completely into larger systems. Those violent interactions are one of the great engines of galactic change. But in emptier regions, that pressure eases. A remote system can spend much longer evolving without being shoved, shredded, or transformed by a major neighbor. Its disk may remain cleaner. Its motions may preserve older patterns. Its supply of gas may last longer because it has not been stripped away by a dense environment. This does not mean nothing ever happens. Small companions can still arrive, and internal processes can still drive dramatic change. But the overall biography is often gentler. Studying such systems lets astronomers ask a beautiful question. What does a galaxy become when much of the universe simply leaves it alone for billions of years? Void galaxies help reveal what the universe looks like without interference. They are useful for the same reason a quiet room reveals sounds that a busy street would drown out. In crowded clusters, galaxies are constantly influenced by their surroundings. Hot gas can strip away their fuel. Neighbors can distort their shapes. Repeated encounters can stir starbursts, feed central black holes, or shut down star formation altogether. In sparse regions, many of those external pressures are weaker or rarer. That gives astronomers a clearer chance to study what a galaxy does under more peaceful conditions. Its structure, color, gas content, and star-forming behavior may reflect a slower and less interrupted history. This does not make such a system simple. Internal gravity, feedback from stars, and hidden dark matter still shape everything it becomes. But the environmental noise is reduced. That is why these remote systems matter so much. They help researchers ask which galactic traits are fundamental and which are scars left by a busier neighborhood that never arrived. Some of them keep forming stars in places that seem almost abandoned. That is one of the most surprising things about them. You might expect a galaxy in an underfilled region to look old, dim, and exhausted, as though the emptiness around it had starved it of possibility. Yet many show signs of ongoing star formation, often glowing with the bluish light of younger, stellar populations. The reason is that what matters most is not whether the wider region is empty, but whether the galaxy still holds enough cold gas to keep making stars. Some do. They preserve reservoirs of hydrogen that can collapse into new generations of suns, long after galaxies in harsher environments have lost part of their fuel. In that sense, remoteness can be protective. With fewer disruptive encounters and less stripping by dense surroundings, a galaxy may continue building stars at a steady pace. So even in a place that sounds deserted on the grandest scale, stellar nurseries can still flare into life. Proving emptiness does not always mean inactivity. The space around the void galaxy can span astonishing distances in silence. Not silence in the earthly sense, because sound cannot travel through that near vacuum, but silence as a kind of cosmic absence. There are fewer luminous neighbors, fewer obvious landmarks, and vastly more underfilled darkness between one structure and the next. The region is not truly empty. Thin gas still drifts there. Dark matter still shapes the landscape. Ancient radiation from the early universe still passes through it. Yet compared with richer environments, the contrast is stark. Imagine a bright vessel crossing a sea so broad that even another distant light becomes rare. That is the feeling these settings evoke in astronomers who map them. The emptiness is not just scenery. It changes how gravity gathers matter over time, how galaxies move, and how structures grow around the edges. A lone system in such a place becomes a marker for the size of the gap itself. By locating the light, astronomers begin to measure the dark expanse that surrounds it. To study void galaxies is to study loneliness on a cosmic scale. That loneliness is scientific, not sentimental, and it opens extraordinary questions. What kind of galaxy forms when the universe gives it fewer neighbors, fewer collisions, and fewer chances to be reshaped from the outside? What survives in that setting, and what never develops at all? Researchers use these remote systems to test ideas about dark matter, gas accretion, dwarf galaxy formation, and the growth of large-scale structure across cosmic time. In other words, a lonely galaxy can tell us something about the architecture of the entire universe. It can reveal where matter flowed, where it failed to gather, and how gravity sculpted both the crowded regions and the hollow ones between them. There is something astonishing in that. One remote island of stars, quietly turning in an immense, underfilled region, becomes a clue to the biggest pattern of all. Its isolation does not make it marginal. It makes it one of the clearest witnesses we have. A cosmic void is not nothing, but it is startlingly close. The word void sounds final, as though these regions were blank holes torn through reality. They are not. A cosmic void still contains matter, radiation, gravity, and the faint leftover glow of the early universe. What makes it extraordinary is the shortage. Compared with most of space, very little gathered there. Galaxies are sparse. Gas is thin. The familiar bustle of the cosmos falls away. That is what makes these regions so uncanny. They are not empty, like a room after the furniture is gone. They are empty like an entire landscape with only a few faraway lights. Astronomers trace them by noticing where galaxies fail to appear, and the missing pattern turns out to be huge, structured, and real. Once you understand that a void is not simple absence, but a place where matter mostly missed its chance to come together, the idea becomes far stranger. It is almost nothing on the grandest scale we know. Void galaxies often sit on faint hidden threads of the cosmic web. Even the loneliest galaxies are rarely floating at random. The universe is arranged in a colossal network called the cosmic web, where matter gathers into filaments, walls, and clusters, leaving wide, underfilled regions between them. Inside a void, that web does not disappear completely. It becomes thinner, paler, and much harder to trace. Some remote galaxies seem to sit along these delicate internal strands, like a few beads left hanging on nearly invisible wire. That detail changes everything. It means the emptiest parts of the cosmos are not featureless deserts. They still contain structure, only in a much fainter form. Those subtle threads may guide thin streams of gas across immense distances, helping a lonely galaxy survive where it otherwise might have run out of fuel long ago. So when astronomers find one of these isolated systems, they are not just seeing a galaxy. They may be catching a glimpse of one of the faintest surviving lines in the universe. Even the emptiest voids still contain dark matter shaping what survives. If you could somehow erase every star and every glowing cloud, the deeper architecture would still remain. Dark matter does not shine, yet its gravity helps decide where galaxies can form and where they cannot. In a void, there is less of it than in richer regions, but there is not none. That hidden mass is one reason a lonely galaxy can exist at all. A remote system still needs an unseen halo to gather gas, hold stars in orbit, and keep itself from flying apart. This gives voids a special power in astronomy. They let researchers study what the universe can build when the invisible scaffolding is thin and the supply of matter is limited. A galaxy inside such a place is not only beautiful, it is improbable. It tells us that even where the cosmos seems to have neglected construction, gravity still managed to gather enough material to light a small island of stars inside a sea of scarcity. Many void galaxies are smaller, bluer, and richer in gas. That combination is one of the clearest clues that environment matters. Smaller often means a galaxy did not bulk itself up through repeated major mergers. Bluer usually points to younger stars because hot newborn stars shine with a cooler colored light before they burn out. Richer in gas means the raw material for future stars is still there, waiting in reserve. Put those pieces together, and a picture begins to form. Many of these remote systems seem to have lived slower, less crowded lives than galaxies in dense groups and clusters. They have often kept their fuel for longer, and that lets them continue forming stars while other places in the universe have already grown quieter. They are revealing. They show what can happen when a galaxy is given time, space, and fewer violent interruptions. In a way, their blue glow is the visible sign of patience written into the structure of the cosmos. Their quiet surroundings can preserve clues erased in crowded regions. Busy environments are rough on memory. In dense clusters and rich groups, galaxies tug on one another, lose gas to help surroundings, and get repeatedly stirred until old traces are blurred or destroyed. A sparse region can be kinder to history. A remote system may hold on to cleaner rotation, more extended gas, and subtler patterns in its stars than a similar galaxy living in a crowd. That makes these lonely systems valuable to astronomers because they can preserve records that busier neighborhoods tend to overwrite. It is a little like finding an old manuscript in a dry cave instead of a damp city cellar. The information survives because fewer forces kept damaging it. In that sense, emptiness becomes an archive. It does not freeze a galaxy in time, but it can leave more of the older handwriting visible. When scientists read those preserved patterns, they get a rarer look at how galaxies grow when outside disruption is reduced. In the emptiest regions, a single galaxy can seem impossibly isolated. The word isolated sounds mild until you understand the scale involved. On Earth, isolation means a cabin in the woods or an island in the sea. In cosmology, it can mean a luminous structure containing billions of stars, yet still sitting in a region where the surrounding matter is astonishingly sparse for tens of millions of light years. Some of these systems are not merely on the edge of a void. They sit deep within it, far from the richer filaments where galaxies usually gather. That makes them valuable and strange. Astronomers can compare them with similar galaxies in crowded settings and begin to separate what comes from internal physics from what comes from external disturbance. The result is almost like a controlled experiment written across the sky. A single remote galaxy becomes more than a distant object. It becomes evidence that even in the deepest, underfilled parts of the cosmos, gravity still managed to gather enough matter to build something luminous, structured, and enduring. Some void galaxies may have evolved with fewer galactic scars. A galaxy can carry the marks of a rough life: warped disks, torn tails of stars, missing gas, swollen halos, and distorted shapes can all hint at old encounters and long gravitational bullying. In a crowded region, those marks pile up. Close passes are more common. Mergers happen more often. Even near misses can leave lasting damage. In a void, many of those external blows are rarer. That means some remote galaxies may have spent billions of years avoiding the worst of the cosmic traffic. They still change, of course. Stars explode, gas clouds collapse, and internal structures grow and fade. But the large outer form may stay less battered. That is scientifically precious. A galaxy with fewer obvious wombs can reveal which features arise naturally from its own gravity and star formation, and which ones usually need a hostile neighborhood to appear. Sometimes the absence of scars tells a deeper story than the scars themselves, because it shows what the universe builds when it interferes less. Void galaxies can rotate peacefully without frequent gravitational harassment nearby. Galaxies are not static ornaments. They're vast rotating systems, with stars and gas moving in grand patterns that can remain orderly for immense stretches of time. In crowded regions, that order is constantly at risk. Passing neighbors tug at disks, stir asymmetries, and inject chaos into what might otherwise be a graceful rotation. In a void, the situation can be very different. A galaxy may keep its spinning structure for longer because there are fewer intruders to jostle it. That long mechanical calm can preserve thin disks, subtle spiral patterns, and extended gas layers that would be easier to disturb elsewhere. There is something almost startling about that. A wheel of billions of stars can turn through deep time in one of the loneliest environments in existence, not because gravity is absent, but because outside interruptions are rare. In those cases, isolation becomes a kind of protection, allowing motion to remain elegant across epochs almost beyond imagination.